Okay. The last example we're going to do is McDonald's states that their medium fries has I don't know what seems like a reasonable number of fries to be in a medium fries box.
44.
It's more than 40. 120 fries.
That's a lot more medium. They're too cheap for that.
I don't know. We'll,
He's making this up.
McDonald's is stating it. They can say whatever they want.
They're lying. They're not 120.
And one nugget medium fries has 120 fries.
Can you like put down like the data that says they only have like 60?
You believe this is too high of a claim. You order 8 things of fries. You order 8 things of fries and record
I have no idea. But this is fluff, not stuff.
a number in each. And here's the results you get.
Like one of our workers was feeling kind of generous that day, and they just like shoved them in there.
Yeah, seriously, that's what they tell us when we work there. They're like, you're supposed to fluff, not stuff. But if you get it one from me, it's gonna be stuff.
Stacy said that when she worked there, it was pickles are lovers. Pickles are friends, not lovers. You should put the pickles beside each other, not on top of each other.
That's true, because I'll be like 3 pickles in the middle. It's like 2 people
You should have added just like
Okay.
25 still recording.
That joke will be out on the internet.
McDonald's states that their medium fry has 120 fries. You believe this is too high of a claim? You order 8 things of fries and record the number in each. 82, 88, 96, 81, 98, 89, 98, and 102.
And when they ask for the proof, you can't present it. You know why? Because you ate them.
Can you dispute this claim? At the alpha equals 0.1 significance level. So when we read through this, does anywhere it say it is known that McDonald's medium fries have a standard deviation of 7 fries? No, there's no standard deviation like that. So we do not know the population. So sigma is not known. That tells us this is going to be a t-test. Correct. We're going to use our t-chart. So step 1 is you always set your significance level. That's being done for us. Alpha equals 0.1. Step 2 is you write out your hypothesis. The null is you always give them the benefit of the doubt. You say, okay, let's just assume that you're correct. So the null is mu is equal to 120. You're just going to go with the claim and say, okay, we're going to assume that you're not lying. So we'll say, let's test. We're going to say that the null is mu is equal to 120. And our alternative, you believe this is too high. So if you're trying to test something and you believe it's too high, you're testing that it's actually what? Less than. So we're going to say our alternative is mu is actually less than 120. So is this a one tail or two tail?
One tail.
It's a one tail. And are we going to shade to the left or right?
the left.
Less than is to the left. Okay, so that's what should be coming to mind when you write that. It's a one tail because we're testing that it's actually less than. We're going to be shading to the left because it's a less than. To do our next step is our test statistic. We know that it's going to be T. We said that at the very beginning. Population standard deviation not known. This is a t-test. So we need to fill in this formula. The formula for t is the sample mean minus the null.
The angle that your card is the shadow of your hand.
Yeah.
Really messing me up.
The sample mean minus the null divided by the standard deviation of the data over the square root of n. So this is the sample standard deviation.
I still have my folder for this class. Not long.
We know that the null is 180, right? No, not 180. 120. That's the null. We know n is 8. N is the sample size. We're looking at 8 orders of Friday to make our prediction. We do not know x bar or s of x, but we can get that by typing this in as a list
Oh, yeah.
on our calculator.
You mean just read it, please?
I won't just go through it one time to make sure everyone's okay.
All right.
So we're going to go to stat. We're going to edit our list. I'm going to clear list 1. And then we'll type in my data. 82, 88, 96, 81, 98, 89, 98, and 102. And then we're going to do calculate one variable stats on list 1. We get x bar is 91.75. S of x is 7.87. Okay, and I'm going to make a note here. This is from the calculator. So if you go back in your notes, you will know where those numbers came from. We got those from the calculator. And then we're going to fill in the formula. T is equal to x bar, that's what we got, our sample mean, 91.75, minus the claim, over our sample standard deviation, over the square root of our sample size. That's the formula for standard error. Working out the top, 91.75 minus 120 gives us
Negative 20.
okay. On the bottom, 7.87 divided by the square root of 8 is 2.7825, if you will. And dividing these two answers, we get negative 10.16.
I got negative 10.555.
I just got
I
negative
got
10.6.
negative 10.16, but I rounded different.
And I have the same point.
Here's typing it all. Here. Parentheses, 91.75 minus 120 divided by parentheses 7.87 over the square root of 8, close. Negative 10.15.
Yeah.
If you don't round at all. Alright, close enough. Now, the dilemma is, if we go to our t-chart, our t-chart does not have a way of working backward for this. Okay, our t-chart does not have a way of working backward. On the other charts, we can find a t critical. We can't find negative 10.16 here. We can find a z critical, and then we can work backward. So, when we get to this, we're actually not going to be able to calculate a p-value. You're not going to be actually able to calculate a p-value. So, here's how you're going to make your decision when you do a t-test. Here's how you're gonna make your decision when you do a t-test. You're going to draw the curve out. Is this a one tail or a two tail? It's a one tail and it's to the what? Left or right or center? To the left. Okay? This one tail is going to be our entire fail to reject region. We know how much that is. We said it at the very beginning. What was it? Alpha equals 0.1. If this was a two-tail test, we would still have alpha equals 0.1, but that would be split up into two tails. Does that make sense, everybody? So then each tail would have alpha equals 0.05. Everyone okay with that? Yeah. But we're talking about a one-tail test, so our entire 10% of our fail to reject is in that one tail. Now, the only way that we can work this T-chart is if we know our confidence interval that we're dealing with, right? Our T-chart at the bottom gives us our confidence intervals. So we need to be able to come up with a confidence interval. So even though this doesn't pertain to this problem, we're going to say, let's add its mirror image over here. Because if you add its mirror image, in between you create a confidence interval. If you add its mirror image, what's the percent of data right here? 0.1. Right?
Yeah.
We have 0.1 below here, 0.1 above here. How much is in between? 0.8. So what we're dealing with is we're dealing with an 80% confidence interval. We're dealing with an 80% confidence interval. Now, if this would have been alpha equals 0.1, but it would have been a two-tail test, then that means that we would have split this 0.1 into 0.05 and 0.05, making the confidence interval what? 90 in between. Does that make sense?
Yeah.
Okay. So we're dealing with an 80% confidence interval. So now we have enough information to use our chart. We're dealing with an 80% confidence interval. And we have a degree of freedom of 7. So what's T critical equal? We go to the 80% confidence interval column on our T chart. We go to 7 degrees of freedom. If we go to our 80% confidence interval column, this first column, we go all the way up here to 7 degrees of freedom. We get a T critical of 1.415. Is it 1.1415? I think I said it wrong.
Yeah,
I said it wrong, but that's the right number.
Is it really?
No,
Yeah,
it's 415. It's not.
There's no 1 in front of the 4.
1.415.
Yeah,
Thank you. It will make a difference. It will make a difference. Here's why it will make a difference. We're dealing with an 80% confidence interval. So if we conduct a sample and we've done it accurately, 80% of the time we should get an answer that's within 1.4, basically, standard deviations of the claim. What was the T-score of ours? Negative 10.16. So if this is negative 1.4 and this is 1.4, does negative 10.6 fall in between those two? No, negative 10.6 is way over here. Is it in the fail to reject region?
Yeah.
Yes. So we fail to reject the null. I wrote this wrong. This is not the fail to reject region. The shaded region is the reject. The non-shaded region is the fail to reject.
Whenever you create a memorandum, essentially, you put all RAM.
The tails are your rejection. The in-between is the fail to reject. I wrote that wrong.
Why aren't you guys speaking up and stuff like that?
I wondered.
Yes.
Like, I won't even understand this until maybe.
So, okay, now look at this. For an 80% confidence interval with a degree of freedom of 7, 80% we should have T critical should be somewhere between negative 1.4 and 1.4. We've got a T value of negative 10.16. That's way off beyond that. That's in our rejection region. So therefore we reject H sub O. So we don't have a p-value method to do this. This is the concept you have to
So do you have to use z-scores instead to reject?
That is how you do a T.
That's what
That's how you do a T test.
I was gonna ask you. Yeah, I was gonna ask you before you did that if you could use the z-score.
You can. Because this is a T test, not a Z test.
I meant the t score.
That's what we just did, yeah.
No.
T,
Never mind. Never mind.
we can't calculate a p-value for T
Yeah, I know.
negative
Then I was gonna
10.16.
ask you when you said that.
So
before you
we'll
did all
just
this.
use T criticals
Okay.
as a way. Kind of like we would do, we didn't always have to use p-values earlier. We could do, how does the z-score compare to 2, right? If it was less than 2, that's acceptable. If it was more than 2, we said it's unacceptable.
I keep getting negative 10.555. And I keep on putting it in the calculator.
Okay, so last step is to report.
Yeah, yours is great.
The last step is to report. So we'd say, I'm going to shorten this. Based on sample n equals 8, median price. There is statistically significant evidence to reject McDonald's claim. I'm not going to actually write out what the claim is. You can read the claim. To reject the fact that their median fries have 120 fries in the box.
Can I write that on my project? I don't have to write it.